Hey guys, I'm Miss Peterson, and today we're going to be talking about the mole. Super important concept in all chemistry classes. So what is a mole? This is a mole. He lives in the ground. But we're not talking about that kind of mole. Marilyn Monroe had a mole, but we're not talking about that kind of mole either. What the mole is a unit. It represents a number. Just like when you say a dozen, it means 12. Or when you say a million, that means a 1 with 6 zeros after it. The mole is just like that, but it's a big number. It is 6.02 times 10 to the 23rd. It's called Avogadro's number, and it means that there are 6.02 times 10 to the 23rd atoms in a mole, or molecules in a mole, or particles in a mole, or bananas in a mole, or pigs in a mole, or moles in a mole. Anything. It just means per mole. Okay? That's 602 with 21 zeros after it. That's a big number. So, before we talk about all these atoms and moles of atoms, what is an atom? It's the smallest part of an element that is still that element. It's made of protons and neutrons and electrons. And then we got molecules. Molecules are when you get a bunch of these atoms and they are chemically bonded together. They're also pretty small. That little pile of aluminum, that's a mole of aluminum. It contains 6.02 times 10 to the 23rd atoms of aluminum. 18 milliliters of water, just that little bit, that is 6.02 times 10 to the 23rd molecules of water. Each of these little metal blocks, each no bigger than a quarter. See, look, I have them here. Each of these blocks contains 6.02 times 10 to the 23rd atoms of that metal. Okay? Notice they're different sizes because it depends. But we need to understand how big this number is. 6.02 times 10 to the 23rd. It's a lot. Because atoms are really, really small. So let's say I had a mole of grains of sand. Okay? Grains of sand are pretty small too. Okay, so if I had a mole of grains of sand, do you think I'd have as much sand as a beach? More than one beach. It's estimated that the grains of sand in all of the world's beaches combined total about a mole. A mole is a lot. 6.02 times 10 to the 23rd is a big number. What if I had a mole of pennies? 6.02 times 10 to the 23rd pennies. Think I'd be rich? I'm a really generous person, so I'm going to share them with everybody in the world. Everybody on Earth would have $890 billion. And say that's not what I wanted to do with those pennies. I wanted to stack them. If I stacked them, it would span not just our Milky Way galaxy from the outer orbits of Pluto, but nearby galaxies as well. Be a really big stack of pennies. What about a mole of seconds? 6.02 times 10 to the 23rd seconds. That's a long time, probably. Do you think I've been alive for a mole of seconds? Do you think you've been alive for a mole of seconds? Probably not. That's 4 million times longer than the Earth has even existed. Okay? What if I had a mole of moles? Like, the moles that live in the ground that I showed the picture and said we weren't talking about earlier. Okay? If I took all those moles and I squished all 6.02 times 10 to the 23rd moles together, and their gravity started acting on them, and so in the middle you just have this yucky mole soup thing, it would still be bigger than the moon. Okay? But a mole of atoms. A mole of atoms is a reasonable amount. We can measure a mole of atoms, and that's what molar mass is. Molar mass is how many grams 1 mole of that atom or molecule weighs. The molar mass of aluminum is 27 grams per mole. That means 6.02 times 10 to the 23rd atoms of aluminum has a mass of 27 grams. Molar mass of water is 18 grams per mole. So if I have 6.02 times 10 to the 23rd molecules of water, it's going to have a mass of 18 grams. And because the density of water is 1 gram per milliliter, it's going to have a volume of 18 milliliters. Molar mass of metals, this one is platinum. It has a mass of 195 grams. Silver, 108 grams. Lead, 207 grams. And copper, 63 grams. They each contain 6.02 times 10 to the 23rd atoms. Okay? They just have different masses and different densities. So what I want you to take away from this is that atoms and molecules are really, 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 really small. They're everywhere, okay? We can't see them. It's not like you can look at a microscope and watch them, unless you have one of these big scanning electron microscopes that take up an entire room. Then we can get images like this. This is an scanning electron microscope picture of graphene, where each of these little fuzzy dots, those represent carbon atoms. So you can see the structure of graphene. But we can see a mole of atoms or molecules. Okay? Okay, cool? Okay, cool. Hey, and that's Avogadro's number. Don't forget it.